Here's an overview of the essay question. I'm just going to sort of help you with your plan really. This was pretty well covered actually. And the three areas that we want to talk about. We've got the role of the loop of Henle. And we've got using the data, identify which animal each nephron relates to and explain your choices. And then we've got a third job, describe how hormonal control could affect the volume and so on. Okay, so your essay is going to really talk about the loop, from your notes. It's going to be looking at these and deciding which one's which. So you're going to do X, Y and Z to the animal, and then you're going to talk about osmoregulation, talking about ADH. So things that you might be saying. So if we sort of took our loop here, let's look at our kind of average loop, then we've got water leaving our descending limb by osmosis. So that's the thing happening there. So that's the descending limb, and our ascending limb, we've got, for example, sodium, and that is active transport. So we've got water leaving by osmosis, we've got a high concentration of sodium at the bottom, and going up here we're getting the sodium actively transported out. The result of this is that this lowers water potential in the medulla, which is this sort of area here. And that's going to relate to our story later on. So we need to say we're in the medulla, we are actively pumping out sodium from the ascending limb, water is being drawn out of the descending limb, so it's permeable to water, and it's moving out by osmosis into the medulla, and could be then taken up by the vasorector, and water can't come out the ascending limb. So that's your loop of Henle, that's what you're going to talk about. Then I think nearly everyone got the animals the right way around. So our long loop was our xeric habitat, so that was our kangaroo rat, and our short loop was our beaver. And the thing that quite a lot of people didn't do was really relate the data to that. So talking about numbers. So for example, the beaver having a more concentrated urine. Sorry, the beaver having a low concentrations, it's 520, and kangaroo rat having a high concentration. And you can relate this to your loop of Henle. So longer loop means more pumping out of sodium and more osmosis of water. So you're getting the data onto the longer and shorter loops. So longer loop for the kangaroo rat, lives in a habitat with not much water, it's producing, that's the wrong data, 5500. So the kangaroo rat, 5,500 urine concentration. Now it's going to produce a small volume of urine, and you're going to relate this to the theory that you've just given, which is in a longer loop you're going to have more water leaving by osmosis and more active transport of sodium, and down at the bottom of the loop you're going to have a higher concentration of sodium. And if you're like me and get the data all over the place, do check that you've done it all the way around. And you could talk about the cat in the middle, of course. Then for the final part of the essay, you're talking about osmoregulation and ADH, and it says when water availability is low. So you're saying, water potential is low. Okay, and it's easier to talk about water potential than solute potential and pressure potential and all that sort of thing. So low water potential in the blood. So that's the problem. Not much water to drink, and so you're not going to have much in your blood because the water will get into your blood through your digestive system. And then you need to sort of say how that is detected. So you're going to say osmoreceptors, you're going to say where they are. They're in the hypothalamus. Most people were fine with this. Then you're going to say that's going to lead to secretion of ADH by the pituitary. So ADH secreted by pituitary, I can't spell it, pituitary gland. Some of you have said posterior and so on. And then what happens is that makes the cells of the collecting duct more permeable to water. So cells of collecting duct more permeable to water. And you could go on to talk about insertion of aquaporins and how that exactly happens. But the outcome of this is that more water will come out, just like it does in the descending limb. More water will be able to come out into the medulla and essentially back into the vas rectum, back into the body. So more water moves to the medulla by osmosis, and then that will get into the blood vessels that are all over here, the vasa recta, and eventually we will get, just like the kangaroo rat, will get low volume of high concentration urine. So low volume, high concentration of urine. So you just need to put that all into nice sentences and without all my spelling mistakes and little errors, and you'll get 9.